Welcome to RHCSA.GURU. Today we'll explore how to work with files and directories using Linux Command Line Interface CLI, where we'll learn essential commands for managing your file system. We'll master the basics of navigating, creating, modifying, and organizing files in Linux. Step 1. Let's get started by opening our terminal. Just click the hamburger menu in VS Code, select Terminal, then click New Terminal to launch our command workspace. If you're using Mozilla Firefox, you can copy and paste commands normally. If you're using Chrome or another browser, you'll need to type the commands manually into the terminal. Step 2 in this, we're going to explore the Linux file hierarchy. Linux organizes files in a structured way, and understanding this structure is essential for system administration. To begin, we'll use the man command to open the manual page that explains the file hierarchy. This will give us detailed information about important directories. Modern Linux systems using systemd follow a file system hierarchy inspired by Unix, defined by the file system hierarchy, FSH, and here, 7 standards. Extensions like the XDG base, directory specification, and XDG user directories help organize user files, configuration files, and cache for a cleaner system. This structure is more streamlined and secure due to stricter systemd guidelines. Press Q to exit this manual and return to the terminal. In Step 3, we explore the /etc directory, a crucial part of the Linux file system that stores system-wide configuration files and settings. As you can see, there are files like password for user accounts, stab for disk mounts, and hostname for the system's network name. There are also directories like cron.daily, cron.weekly, and systemd that manage scheduled tasks and system services. This directory is vital because any changes here can directly impact how the system functions. That's why it's important to understand what each file and folder does before making any modifications. In Step 4, we're exploring the /usr directory, which stores user applications, libraries, and documentation essential for system operations. In the terminal, you can see important folders like bin for user programs, lib and lib64 for system libraries, spin for admin tools, share for shared data, and local for user-installed software. The /usr directory is mainly for software and files that aren't critical for booting. Let's continue to the next step. In Step 5, we're exploring the /var directory, which stores files that frequently change or grow, like logs and caches. In the terminal, you can see folders such as log for system logs, mail for user emails, spool for queued tasks, cache for temporary data, and tmp for temp files. These files are vital for system activity and performance. In Step 6, we're exploring the /tmp directory, which stores temporary files created by applications and processes. As shown in the terminal, there are system-generated files like systemd private and .soc files used for inter-process communication. These files are automatically cleared after a system reboot or over time. The /tmp directory helps applications run smoothly by handling short-term data. In Step 7, we are learning how to create files and directories in the workspace using basic Linux commands. First, we used the touch command to create 2 empty files named courses and results. The touch command is commonly used to quickly create new, empty files. Next, we used the mdir command to create 2 directories called docs and workbooks. The mdir command is specifically for making new folders or directories. To run both commands together in a single line, we used the and operator. After executing the command, we can now see that all the files and folders were successfully created in the workspace. Now in Step 8, we're learning how to copy files using the cp command. Here, we copied the courses file into the docs directory, creating an exact duplicate without altering the original file. This ensures that the original file remains safe while the copy can be used or modified as needed. As you can see in the workspace, the file was successfully copied and verified. We've checked this step, and everything is working perfectly. Let's continue to the next step. In step 9, we verified that the courses file was successfully copied into the docs directory. This step ensures that the file was placed in the correct location without any errors. By listing the contents of the docs directory using the absolute path, we can clearly see the courses file inside. This confirms that the copy operation was completed successfully, and everything is working as expected. Verifying file locations like this is a crucial habit in Linux, because it helps ensure that files are correctly placed and prevents accidental data loss or mismanagement. Regularly checking file paths and directory contents allows you to catch errors early. In step 10, we move the results file into the workbooks directory using the mv command. The mv command is commonly used to move files and directories from one location to another, but it can also be used to rename files and folders. This makes it a powerful tool for organizing and managing files within the system. After executing the command, we can clearly see in the workspace that the results file has been successfully moved into the workbooks directory. Additionally, the task is marked as completed, confirming that the operation was successful. Mastering file movement and organization is essential for maintaining a clean and efficient file structure in Linux. In step 11, we're verifying that the results file was successfully moved to the workbooks directory. By listing the contents of /home/coder/workspace/workbooks, we can clearly see the results file is now inside. This confirms that the move operation was successful and the file is in the correct location. Regular verification like this helps avoid mistakes and keeps files well organized. Let's continue to the next step. In step 12, we deleted the results file from the workbooks directory using the rm command. The rm command is a powerful tool in Linux that permanently removes files, so it must be used carefully since deleted files cannot be recovered. After running the command, we can clearly see in the workspace that the results file has been successfully removed. The task is also marked as completed. Let's continue to the next step. In step 13, we deleted the now empty workbooks directory using the rmdir command. This command is specifically used to remove empty directories. After running the command, you can clearly see that the workbooks directory is no longer visible in the workspace, and the task is successfully marked as completed. Removing unnecessary and empty directories not only keeps the system clean, but also makes it easier to navigate and manage files efficiently. This practice is especially important in larger projects where clutter can lead to confusion and errors. Let's move on to the next step. In step 14, we deleted the docs directory using the rm command. Since the docs directory wasn't empty, the R option was necessary to remove it recursively, meaning it deleted the folder along with everything inside it. This makes the command incredibly powerful for cleaning up directories, but it also means we need to be very careful to avoid deleting important files by mistake. After running the command, you can clearly see that the docs folder is no longer visible in the workspace, and the task is successfully marked as completed. Staying cautious with commands like this is key to managing files safely and effectively. Let's move on to the next step. In step 15, we verified the successful deletion of the docs directory by listing the contents of the workspace. This step ensures that the command we executed worked as intended. The docs folder is no longer visible in the workspace, clearly confirming that it was permanently removed from the system. Let's move forward to the next step. In step 16, we are copying all files from the /etc directory that start with the letters A or B into the current directory. This is done using the command cp/etc/obstar. Here, * is a glob pattern that matches any file beginning with A or B, and the dot represents the current directory. However, as seen in the terminal, we received warnings like cp are not specified, omitting directory. This means the command only copies files, not directories. To include directories, we would need to add the R flag for recursive copying. Understanding how these patterns and options work is essential for efficiently managing files in Linux. Let's continue to the next step. In step 17, we used the ls.l command to display detailed information about the files and directories in the current workspace. This command provides important details like file permissions, ownership, size, and the last modification date. For example, we can see the permissions on the left, the file owner and group in the middle, and the file size and date on the right. Now Step 18. In Step 18, we learned how to redirect the output of a command into a file using the operator. Here, we used ls_output.txt to save the output of the ls command into a file named output.txt. This means that instead of displaying the file list on the terminal, it gets stored inside this text file. If output.txt already existed, this command would overwrite it with the new content. If it didn't exist, the system automatically created it. Let's move forward to the next step. In Step 19, we verified that the output.txt file correctly contains the output of the ls command. By using the cat output.txt command, we displayed the contents of the file. As shown, it lists all the files and directories that were present when the ls command was executed: AGTime, aliases, anacrontab, basic, courses, and even output.txt itself. This confirms that the output redirection worked perfectly, and the data was properly saved. Redirecting and verifying command outputs like this is a great practice for logging and reviewing system information. It helps in tracking system changes, debugging issues, and keeping a record of important data. In Step 20, we learned how to append data to a file without overwriting it. Using the operator, we added the text all directories to the end of the output.txt file. This is different from the operator, which would have replaced the file's content. As shown in the workspace, the text was successfully added beneath the previous content, and the task is marked as completed. This method is great for keeping logs or adding updates to files without losing any previous data. Let's continue and explore more. In Step 21, we used the cat output.txt command to verify that the new content was successfully added to the file, confirming all changes were correctly applied. Now you can see the updated content displayed clearly in the terminal. This ensures that our file operations were successful and the data is accurately stored. Let's move on to Step 22. In Step 22, we used the to operator to redirect error messages to a file. The command ls non-existent file to error.txt tried listing a non-existent file, generating an error that was saved in error.txt instead of displaying in the terminal. This is a powerful way to log errors for easier debugging and maintaining a cleaner terminal. And as seen, we successfully checked the captured error in the error.txt file. Let's move on to the next step. That is Step 23. In Step 23, we used the cat error.txt command to verify that the error message was successfully redirected to the file. The content displayed confirms the error, ls, cannot access non-existent file. No such file or directory. Now Step 24. In Step 24, we used the command ls d/tmp/*/ to list only the directories within the /tmp folder. The D flag ensures that the command lists directory names instead of their contents. In Step 25, we used the command ls lrt/etc to list all files and directories in the /etc directory. The L flag displays detailed information, including permissions, ownership, size, and modification date, though our flag sorts the results in reverse order. The T flag sorts files by their last modification time. As shown in the terminal output, the files are organized from the oldest to the most recently modified. Let's continue to the next step. In Step 26, the command ls/etc tail-5 lists the last 5 items in the /etc directory. ls/etc shows all items. Passes the output to the next command. Tail-5 displays the last 5 entries. This is a quick way to view the most recent or last few items in a directory. Now Step 27. The command ls/wcl is used to count the total number of files and directories in the current location. ls lists all files and directories. The pipe sends this list to the next command. wcl counts the number of lines, giving the total item count. Here, The output 7 confirms there are 7 items in the directory. Congratulations! You have successfully completed the Manage Files using CLI.